Okay, so welcome everybody. So for those online, the room is, I would say, lively but relatively small. We got a handful of folks in here that I'm actually really excited to talk to. So I am looking forward to this conversation. Um, as for online, we got 9 folks online right now, and hopefully we'll be joined by a couple more soon. So just as by way of introduction, so this is the drone cluster. And just to give a quick introduction to the co-chair, so myself, I'm Lindsay Barbieri. I recently graduated from the University of Vermont with a PhD in natural resources. I use drones fairly extensively in my own research, which focused on agriculture and general sort of geospatial technologies, looking at agricultural dynamics. And I'll let my other co-chair introduce herself real quick, is Jane Weingart. Jane, if you
Hey,
want to go.
I'm online because I'm in South Africa, and I recently worked for the University of Cape Town. I'm an electrical engineer. I used to work in the US, hence connection to ESA.
Yeah, thanks. So, great. So that's who we are. Um, by way of introduction of the cluster, I would say that, this cluster has actually been running for kind of a decently long time. So in 2015, we started in a conversation that was literally under the stairwell at an ESIP meeting, where a couple of us were talking about using drones for research and like, wouldn't that be great? But like, what kind of sensors and how would we think about the data, information management systems? That conversation kicked off this cluster, which quickly led into like a small funding Friday project. And then, as you can kind of see here, we've sort of escalated and morphed our activities with a variety of a variety of outputs and actions. So we had a couple of drone user workshops based at ESIP that brought in a lot more folks from sort of the private sector, some drone companies, as well as a lot of federal agencies that were using drones. And from that, and a sort of a longer drone survey that was done by an intern here, that sort of morphed into this ESIP lab project, which was developing a minimum information framework. So thinking about the data coming from drones and how we can think about what information is necessary to make that data usable, reusable, sort of actionable. And from that, we have actually a paper that's currently in review and also contributed to reports with the Long-Term Ecological Research Center there. So there's been like a really, I'd say, exciting and sort of like a really broad amount of collaboration through a lot of this kind of work. We've also, as the drone cluster, myself and Jane, but also others in our community have also gone on to collaborate more internationally with the Research Data Alliance as well, having kind of another drone information data and information group there, doing a little bit more work sort of more broadly in workshops, across many continents. And yeah, and then we've had from all of this sort of collaborative energy, a paper come out in 2019 about the emergent challenges specifically for science within and science drone use and data management in particular. And this also kind of led to this bigger project, the Landers Project, which one of our speakers today will actually talk about as well. Yeah, so no, the mic is being a little funny, so I hope everybody can hear me online okay. So this paints a little bit of the picture. I'm going to just really quickly introduce folks in the room and online to, how we think about, or what when we think about drone data and information management. We're thinking at the drone cluster. We think about the data collection and management side. We think about drone use, the workflows, the legalities. Actually, we were just discussing some of these, like some of the ways that we might think about uh, these sort of like drone use documents, training systems, sort of flight operations. Also, the drone sensors and the drones platforms themselves, the sort of engineering aspects, and then also the data best practices and technology. So these more the information systems and management. So all of this kind of comes together in how we think about the drone cluster. And just to give everybody, again, just like a quick big picture, high level idea of how I think about this is that, you have a drone, it can carry a bunch of sensors, any sort of number of sensors for all sorts of reasons. And there's a bunch of information that might make the data that comes off of this drone really useful, but not all of it is sort of necessarily super obvious or easy to capture. So we think about, or I've been thinking about it in this framework of, there's a bunch of pre-flight information, what scientific questions are being asked, what sensors are being used, what platforms are being used, where you're putting the sensors on the platforms, how you're calibrating the sensors. There's all sorts of questions that might come at the pre-flight stage that are really important. During the flight, you might want to know, the conditions of the flight path itself that the drone is taking, how the sensors are, mounted or moving with the drone, all sorts of things that might come at the flight level, information that might be really important to contextualize the data that's coming off the drones. And then, of course, post-flight, we have potentially a whole slew of data, and it might look really in a variety of different ways. We might have a bunch of imagery data. We might have a bunch of tabular data, CSVs, coming off of these sensors. Columns might be labeled depending on the sensor. They might not. Like it's, there's a whole things might be geolocated if they're imagery. It might, you might be getting a whole swath of these data products off of one flight, and so understanding like this sort of broader information ecosystem is becomes really important. So again, this is from the minimal information framework paper that I discussed that's currently in review at Data Science Journals. We're trying to really articulate this really well and think about all the sort of the pieces of the drone research workflow and where information management is really important. So that's just by way of introduction. So now I would love to, especially because we actually have like, I think a good number of people online and in the room, is just do a quick like round the room introduction. So we're going to introduce ourselves. Thank you, Jim. It's going to run around a microphone so we can hear from folks. And I would just say maybe in like a sentence or two, just talk, if you could introduce yourself and just talk about like, are you working on drone projects at all? And if so, like, just a quick overview of what those might be. And if not, totally fine. Maybe why you're interested. Yeah.
I'm Andrew Child. I'm a data manager at the University of Idaho. Currently working on their NSF Export Gen 3 grant, which a large component is UAS data. So building them platforms where they can record flight data and store data and share data. So I'm Chris Crosby. I wear two hats. I work at UNAPCO. Right after the JEDEC imaging program, which includes UAS support. Various community PIs are doing broadly geodesy, but generally shaping the earth and change the shape of the earth. Technologies like these are still. I'm also co-PI of the Open Topography Project, which is doing a lot of data management, built to make it easier for people to publish data that we'll present in a second. But we're interested in topographic data collected with drones and other. Hi, everybody. I'm Cole Speed. I'm a graduate student at the University of Texas. In the summer, I'm working with open topography as well. And I use drones in my research to collect data for building outcrop models, and also for understanding river dynamics.
Hi, I'm Deborah Smith. I lead the Airborne Data Management Group for NASA. And my latest task has been to develop best practices for drone collecting data for science data. I'm Terry Belgia. I'm with the Oak Ridge DOE Oak Ridge National Lab, and I'm data lead on 2 projects. And while I don't have personal drone data, I have people across the 5 institutions or labs that are working with us. We've got one group at Brookhaven that is trying to come up with a reporting format, and they're going to be looking for input on that. So we've got something submitted from them in some kind of metadata form. They've been looking at other places, and so I'm kind of here. I learned on the drone cluster periodic. I
I always like to know about lurkers. Thank you. So I think, Philemon, do you want to introduce yourself briefly? Couple words if you work with drones or why you're interested.
Hi, I'm Philemon Gallega with Texas A&M University in Corpus Christi. I'm also with the Gulf of Mexico Coastal Ocean Observing System. I'm here trying to listen about what the drones are doing, what projects are undertaken, but we are not really very much onto drones. We are on sea gliders and AUVs for the water, so whatever you're doing, how you manage all this data from the drones, probably our community also will be able to learn from your experiences. And if you want to tell me what we do with our data, with all these AUVs that we deploy out there, I can always share that particular experience.
Great. So I think for those online, that's everybody in the room. I'm just going to read out. So Alan, you're saying that a bunch of background noise here. So Alan just chatted saying program officer at NSF for Polar Cyber Infrastructure and seeing more drone projects and data. So really interested. So yeah, welcome. That's great to hear. Yeah, excited to have you. If we want to go down online, it would be great to hear folks. If you feel like you can't speak up, feel free to type it in the chat. But otherwise, I know we will hear from. We'll let the speakers introduce themselves. Also around the room. So Chuck, do we want to start with you? You can keep it, keep it short.
Sure. I'm Chuck Vardaman. I'm a research professor at the University of Notre Dame in the Center for Research Computing. I'm co-PI of Landers, which is the linked data API for network drones. And I'll be giving an update in a little bit. I'm co-PI with Jane.
Okay, Matthew.
Good morning. My name is Matthew Lee. I am the platform manager for the Monash University Drone Discovery Platform here in Australia. I also coordinate the Australian Scalable Drone Cloud, which I will touch on a little bit later.
Yeah, wonderful to have you, Matthew. Dawn, you've joined us. Hi, Dawn. Glad you got in. Do you want to give a little introduction?
Can you hear me?
Yeah, we can hear you, Don.
Can you hear me? Excellent. Okay. Hi. Hi, all. Don Sullivan. I'm with the NASA Airborne Science Program at the Ames Research Center, Silicon Valley, California. I've been working at NASA with drones and open standards and open data since the mid-90s and continue to do so, and I'm loving it. That's it.
Okay, great. Thanks, Don. And Hazem, you're saying background noise here too, but you're at the you're an Earth scientist at NASA LARC, Atmospheric Science Data Center, and interested in suborbital atmospheric data. Oh, that's wonderful. Yeah, at Langley. Great. And I think that's all of us online. So with that, yeah, thanks all for the introductions. Oh yeah, go ahead. Oh no, yes, sorry, please.
Forgot me, Lindsay. This is Stefan Clayson. I'm the owner of a private aerial drone survey company called Nearview, based in Portsmouth, New Hampshire. Specialize in environmental applications, mapping coastal marine resources such as eelgrass, macroalgae. Just was recently awarded a NOAA Small Business Innovation Research Grant, Phase 2 grant, to develop a data platform to map macroalgae in the intertidal zone.
Oh, that's great. I'm in Vermont still, so right next door. That's exciting. Yeah, wonderful. Well, great to meet everybody. Great to hear from everybody. And I will now reshare my screen for the agenda, but just so we're all kind of aware and prepared, part of hopefully what we're hoping to do at the end of the session, after our presentations, is to have a little bit of a discussion. This is the first time the ESIF drone cluster has really officially met in a couple of years. And, of course, part of that is COVID related, but also I think that there's potentially a really amazing number of pathways we could go forward in terms of collaboration and ways that we could think about gathering and spaces maybe we should be thinking about being in and how to pull people together in sort of meaningful and collaborative ways. So keep that in mind as we hear from all of our presenters. And yeah, and it would be great to really hear from folks and think about how we can work together going forward. So with that, I think let's go ahead and turn to our 4 speakers. So we have first up Matthew Lee from the Australian Drone Cloud. So Matthew, if you would like to share your screen, I can stop my screen so you can grab it. And Matthew, you're joining us all the way. At what time is it there now? It's quite early for you, isn't it?
It's 20 past 6 in the morning.
Well, thank you so much for joining us. I hope you have enough coffee.
My pleasure. Okay, just give me 30 seconds whilst I share my screen. Where have you gone? Am I? No, I'm not. Sorry, just give me 10 seconds while I'm trying to find the view. There we go. That's what we want. Thank you very much. Okay. All right, let's start at the start. Good place to start. All right, thank you. My name's Matthew Lee, and as I said before, I'm the coordinator for the Australian Scalable Drone Cloud. It is exactly what the name suggests. It's an open, scalable, an open source scalable platform for users of drone data. It delivers a nationally accessible infrastructure for drone-related research and innovation across a range of disciplines, including earth, plant, environmental sciences, as well as archaeology, engineering, and more. The ASDC is a 3-year project supported by the Australian Government's National Collaborative Research Infrastructure Strategy. And the organisation ARDC, TURN, APPF and AuScope, together with CSIRO, are commenced commenced the project in the 3rd quarter of 2020. Since then, development of the various components and integrations of the ASDC have been shared across these partners, and we're working together to get a deliverable, an MVP out by Q4 2022, with additional features, tools, improvements, and features to be delivered in the intervening 12 months. So hopefully our platform will be ready for use by Q4 2023. We're hoping that our platform, well, we're all probably familiar with a workflow like this, but we're hoping to create a seamless pipeline of data from capture through to publishing by integrating data management tools, a structure from motion engine, a Python coding environment, a data visualization and interrogation tools, and a drone discovery data dashboard for publishing sharing of data. All this is delivered through an online web interface and hosted on scalable computing hardware. So one of the principal goals is that the project is fair. The platform is being built with the goal of accelerating widespread adoption of the FAIR principles for drone acquired data from the point of capture to publication. The FAIR principles stand for findability, accessibility, interoperability, and reusability, and describe the useful framework for thinking about sharing and managing digital assets. By adopting the FAIR principles, the ASDC will maximize the use and reuse of all the digital assets that it produces. And really the main implication of using the FAIR principles in the ASDC is that everything that we build has to be open source or using open source tools. So it's currently available on GitHub, and users will be able to either deploy their own version of the platform by copying those GitHub repositories, or use the instance that we run on hardware funded by the Australian government. To inform the development direction of the platform, improve user experience and ensure value is provided to users upon first release. The ASDC is incorporating 3 key test use cases to inform that development. The first is a wheat hub pipeline, which takes drone photogrammetry imagery from over crop plots, processes it through a structure from motion engine, calculates change in crop height over time from the result. Crop height is a good proxy for plant biomass, which in turn is a proxy for yield. Yield is currently one of the primary metrics of crop success, and so being able to easily measure plot height is an essential tool for researchers and breeders. The second use case is a structural geology pipeline, which simplifies and standardizes the translation of drone photogrammetry data into objective measurement of rock surface characteristics. Many geological applications, from environmental safety to optimizing mine sites, will benefit from deriving fracture network maps from aerial photography, tracing fault scarps in digital elevation models, and mapping boundaries in an expedited manner. And finally, the Victorian Coastal Monitoring Program is a citizen science project which collects photogrammetry over 42 sites along the Victorian coastline every month, which is over 500 surveys per year. And the objective is to predict the impact of storms on beaches, to help, is to help measure the impact of storms on beaches across Victorian coastline. This means that, at the scale at which the Victorian coastline sits, means that it's hard to determine whether sand will return naturally after erosion events, or measure the impact of climate change. So having these projects at this scale really helps. However, large-scale projects like this comes at a significant expense, hence why the citizen science aspect is such a valuable one. Citizen science drone surveys are a cost-effective method which both engages local communities in the management of their coastline and delivers high quality, precise and accurate data for researchers and managers. Drones enable rapid surveying of beach volumes and therefore provide critical information for the determination of the dynamics of the beaches around Victoria. So those are the three use cases that are going to be used to inform the development of the platform. Obviously, all three are photogrammetry-based applications initially, but the platform will be able to absorb different types of data post MVP release. So we're focusing on photogrammetry at the moment, but we'll incorporate a more diverse range of drone data outputs in the future. So this is a bit of a busy slide. Don't stress too much about it. All I really want to glean out of this is basically what the key components are. So we want to start with the drone data capture, and we'd like to produce integrated tools so that data can be directly uploaded to our photogrammetry engine, and that is running WebODM at the moment. And then from WebODM, you can produce your digital artifacts, and those digital artifacts can then be analyzed using a Jupyter Hub instance, which is integrated with the platform. So that is the principal analysis system we use, is Jupyter Hub. And that will allow people to develop their own tools, use tools from other researchers, as well as share those tools or publish those tools. We visualize using a system called Terrier and Cesium. So it's all your data is visualized, able to be visualized online, and that is based off the OpenWebGL system. Data storage data storage is a complex one, but we have our own storage, as well as enable users to publish, or at least store their data on their institutional repository. And then final is publishing. So we're creating an integration with Research Data Australia, which allows, which is a platform for the sharing of, it's a data repository again, for the sharing of published data. And it all comes back to the start. So that was a very quick summary of what the Australian Scalable Drone Cloud is trying to accomplish. Thank you for your time. Happy to answer any questions later on, but that's all I had. Thank you very much.
Great. Yeah, thank you, Matthew. And we can take like 1 or 2 quick questions as we go to make it a little bit more interactive. So if anybody has questions for Matthew online or in person. Yeah, we have one in the room. So Philemon's about to ask you something.
Yeah, Matthew, I was trying to understand that very piece of graph or slide after. What is really scalable? Is it the storage system or the distribution system of the data? What was scalable in that particular design?
So the both the hardware and the storage are scalable. So the computing component backend can be is basically the scalable component, but same with the storage.
Great. All right, wonderful. I think we're gonna keep moving. We'll have hopefully, like I said, a bigger discussion at the end. So if you have more thoughts later, please keep them in mind. But for now, I believe we're going to have Crosby come up, and I am gonna pull this up as fast as possible. First, share our screen. This one's yours, right? That looks like me. Looks like you. Wonderful. And so, can minimize this and shift so that we can actually. Oh, yeah. Okay, hold on. Resharing your screen. I know, so many things. And I believe this is where we're at. Yeah, I think it's that one. Okay, wonderful. And you can shift that up. Okay, you can see online? Okay, wonderful.
Okay, and you can hear me okay out there in the internet world without being too loud in this room.
I know, it's like a little
It's like a little,
feedback.
yeah, like
I
feedback.
was like,
Okay, everybody. Yeah, thanks for the invitation. I'm going to talk a little bit about this project called Open Topography, for which I'm a co-PI. I'm based at UNAVCO, which is a NSF-funded facility in Boulder, Colorado, and this is work that we've been doing basically about topographic data for over a dozen years and about web-based management of topographic data and data processing, and have in the last, say, I don't know, 4 or so years started working on drone-generated topographic data. So my perspective here is probably a little bit different than others in the room. We're actually less interested in the UAS component and more about how we manage these types of data sets and how we fit them into the framework we've built for other kinds of topographic data. And again, this is National Science Foundation funded effort primarily. So Open Topography has been around for about a dozen years, and really we started with a focus on airborne LiDAR data as a product that was new and exciting in the earth sciences, but was pretty unwieldy, hundreds of millions to billions of individual XYZ positions from a laser scanner, typically on an aircraft. With a focus really on providing access to data, but also co-location of data with tools to make it easier for people to actually derive products dynamically from data that was living inside of this big archive. So our physical infrastructure is based in San Diego Supercomputer Center, and so we've always leveraged a bunch of computing infrastructure. And our goal is really to make these products easy to use, not to deliver people millions of points that they have to figure out what to do with. So the kind of concept here is how do we take now these UAS type of data sets and put them into that framework. So just many people in this room probably are very familiar with this, but we're interested in.
No, it's okay. I'm just shifting this.
Oh yeah, because that's on top of the screen.
It's like so many. There we go. Sort of.
Sort of. So 3D imaging the landscape, you can do this with lots of different technologies, right? So we can do it from space with things like radar, like the shuttle radar topography mission. You can do it with photogrammetric techniques from space using commercial or non-commercial imagery. Airborne LiDAR for the last 20 or 25 years has been the primary tool for sort of high resolution topographic mapping. And then over there on the right side are kind of the newer, more emerging technologies like hanging a camera on a drone of various costs and sophistication. You can produce this kind of data from a camera on a balloon. You can walk out and take pictures with your handheld camera. You can put a camera on a pole. Your iPhone, many now have LiDAR in them. So what we're really interested in is sort of data in this specific presentation are the data sets on that right side, like that are coming from this. And so, suddenly the slides are not advancing. Yeah, there it goes. Okay, so this is the kind of data set that we're talking about. This is a photogrammetric structure from motion derived data set from Tecolote volcanic field in northern central Mexico. These are very young volcanic features. This is like a DJI Phantom type drone, 2,000 images, 563 million points derived from that. This data set's pretty rich, 309 points per square meter. It's the number of like XYZ samplings in a raster basis. It's not spatially a very large data set. It's on disk, not a particularly large data set, frankly, relative to say like LiDAR data of the United States or something. But it's a very cool and rich and interesting data set for a lot of scientific applications. So the question is, what do we do with this kind of data? And so this is the focus. So I've been sort of like, many of you are familiar in the informatics world with this long tail data distribution, what's been called dark data, where on the left side of the distribution, you have data sets that are relatively large in size, but there aren't that many of them. And then at the other end are these like smaller data sets. They're not particularly well accounted for in sort of the data management infrastructure. This is the dark data or the long tail. And so if you're thinking about this in a topographic data sense, at the left side of the distribution are these data sets that are nationally curated by big infrastructure. So it's like, the USGS 3DEP program, SRTM, data sets produced by the space agencies like TandemX and other sort of big things. There's infrastructure around management for these access to these data sets. But this explosion of UAS type technologies has produced a lot of data in the long tail. So these are the data sets that individual researchers, graduate students, hobbyists are out producing, and generally there isn't a great place to put them. There's no standards for how we manage them. But that doesn't mean they're not necessarily interesting and valuable, especially for doing things like time series analysis, multi-temporal change of landscapes. Previous presenter talked about crowdsourcing and stuff. So there's a lot of really interesting things you can do with these, but there's like not a great framework. And so the system we've built with inside of Open Topography is really meant to address this side of the distribution. We also are dealing with the stuff on the other side. We provide federated access to data sets like the USGS 3DEP collection. But particularly here, I'm talking about the other end. So we built this thing in like 2018, and we've been sort of iterating on it. We call it a community data space. And the idea was that it's a platform for publication of data in that long tail, with a focus on point clouds derived from things like photogrammetric workflows like structure from motion, the raster derivatives you may produce from those points, so DSMs and DTMs, orthomosaics, those kinds of things, as well as the raw source imagery. So those like 2,000 photographs that went into that Tecolote volcanic field, like let's publish those as well so somebody else can recreate that point cloud if they want to. And the idea is to make this as easy for the user as possible and to automate as much of this as possible, because these data sets aren't huge. And so the idea here is like you can drag and drop them into a browser and actually programmatically ingest them into our archive and pull out as much metadata as possible. And for the metadata you can't pull out of the files, you give the user the ability to sort of populate the database. And then you hit go and you basically create a DOI for that object and you publish this data set into OpenTopo, and try to do this in a way that's aligned with FAIR best practices, which was also mentioned in the previous presentation. But this is an example of the screen cap from the ingestion process. So we're pulling coordinate reference system information out of LES point cloud file headers and GeoTIFF headers, and we're calculating the convex hull that bounds the points. And we do this again through a drag and drop interface in a web browser. At some point this breaks because you're not going to push huge data sets through a web browser. So we have a sort of a cutoff where at some point we have had people come to us and said, I flew 10 kilometers of the southern San Andreas Fault, and I've got a data set that's way larger than one of these. And then it's like, okay, well, now we need to talk about like sending it to us on our hard drive or network shipping it, and we'll ingest it like we do a really large airborne LiDAR data set. But a lot of these UAS data sets are pretty small, and they work really well through this process, and it's pretty easy, and it doesn't require one of our data engineers to sit down and like go through the process of running a bunch of data ingestion, and we can automate some of this. So that's kind of the goal with this, and it's been pretty successful. I'll show you in a second. But then the other piece that kind of mimics what was talked about in the previous presentation was sort of the rest of that FAIR process, which is making the data set findable, interoperable, and reusable. And so this is a workflow that's conceptual, but the user comes in at the lower left, they've got their drone data, they upload their spatial products, their LAS files, their rasters, whatever. We do use a bunch of open source tools to do that data validation, that kind of metadata extraction. Then we push that data into a registration holding space where one of our staff looks and is like, okay, this is like complete, checks the boxes. And then we hit publish basically, and we dump that data into an object storage, like S3-based object store for sort of data access. We go get that digital object identifier, so it's now a DOI with a landing page, and then we push that data out through our portal interface for discovery through open topography, but then we also have data catalogs that get federated by other things like data.gov. So here's an example of a data set from the Afar Basin in Ethiopia, collected for like a human origins study of a field site in the Afar, where the data are accessible on the left through open topography. You can navigate to these in a map, you can click on them, you can view them in 3D using a browser-based visualization tool, and download that product. But then also, because it's in our catalog, it shows up in data.gov. So if you do a search for Ethiopia topography, you find this data set via data.gov because data.gov is consuming our catalog service for the web. So it's a nice way to make these data sets highly findable, but also relatively usable. And so that's kind of the vision for this. Status is about 153 data sets have come through this process. And again, the focus is not exclusively on UAS. So there are data sets in each of these purple dots is one or more data sets in a given location. The vast majority of them are coming off of US platforms, but there's also data sets derived from commercial satellite imagery or terrestrial laser scanners, things like that. So there's like one or two drone LiDAR data sets in open topography, but there aren't that many because there aren't that many people yet that are flying those systems because of the cost. It's been an interesting platform because as you can see, the spatial distribution of the data is pretty interesting globally. Like there's a lot of data in Central Asia, and this is open topography has a strong connection kind of with tectonics community. So there's a lot of people flying earthquake fault scarps and things in Central Asia, and these are data sets that are actually really unique because there's not a lot of high resolution topography in these parts of the world. It's the only way you're going to get a sub-meter resolution digital elevation model of a fault scarp in the Tian Shan or something. So they're cool data sets. And then the other thing that's been really interesting is the diversity of the contributors. So we're National Science Foundation funded. Our focus is certainly US researchers, US educators, but I'd say more than half of the contributors are international. So they're Europeans, we've got data sets contributed by Chinese scientists. So it's been a way to surface interesting data sets, again, in that long tail that would probably be very, very, very hard to track down otherwise. And so that's interesting. So functionality-wise, data discovery download are solved. We're now using the Poetry point cloud viewer, which is an open source tool for point cloud visualization. So you've got Tecolote volcanic field image. You can do that for basically any data set in here, all 153 of them. And we're currently working on chaining these data sets into open topography's full processing suite. So for like LiDAR data sets and other data that we've been managing for a long time, you can do things like derive DEMs from point clouds. You can make raster products like slope and aspect and contour lines and all kinds of things. And so we have a beta version of this, but we haven't published it yet. But ultimately, you should be able to take any of these 153 data sets and actually like process them in open topography, which will really be the full realization of reuse of these data in the ways that we want people to be able to reuse them. We also do things like topographic differencing, which is an interesting set of functionality. So these multi-temporal stacks of UAS topography that you can difference across are really interesting for dynamic landscapes. And we've got some groups who are already publishing like annual repeat surveys of landslides and other features that are changing and are a really interesting opportunity to start doing that multi-temporal analysis. And also because we have things like USGS 3DEP, all kinds of global topographic data sets inside of Open Topography, in theory, you should be able to take a drone data set and difference it against like a UAS or a LiDAR data set from say 3DEP or some other project. So we're like 2/3 of the way to realizing that vision, but there's some complexity in that last step that we're still sort of sorting out. So, I think we're in this interesting space with regard to 3 and 4D topographic data collection. We've been using this term ubiquitous point clouds because it's becoming easier and easier for people to go out at low cost and produce these kinds of data sets. But there's some challenges. Bar asked us to sort of highlight some of these. So things like best practices, standards for documentation, especially if you're interested in reuse. Things like how was the survey collected? What are the accuracy constraints on that data set, especially if you want to do multi-temporal analysis? How good is the data? What's signal? What's noise? And then another interesting problem for us, because we're a very grant-centric funded organization at the moment, is sustainability. So when people can produce these data sets, and we built this really to facilitate academic users. We've had people come and be like, I flew a drone over my neighborhood and I want to give you my DEM or I want to give you my point cloud. And like, those are interesting things because it's potentially really interesting crowdsourced data, but it's a little hard to scale and sustain storage of that kind of data at higher levels. So that's the update. Thanks.
Yeah, thank you, Chris. Maybe take one question if we have it as I switch over, and I know Dawn, you're gonna be next, so get ready to share your screen. But in the meantime, any questions for Chris? Yeah, we have one in the room, and if anybody online has one, maybe just type it in the chat so we can do that.
Do you provide a kit for standards and formats you want so that everyone delivers to you something?
Yeah, we have like
pass through validation.
Yeah, we have sort of like a tutorial on like file formats are pretty common. Like these processing tools produce things like LAS, which is a common exchange format for point clouds. That piece is pretty easy. We also have like a template for metadata, survey metadata, trying to encourage people to document things like how they did their ground control, their QA/QC, what their processing workflow was. But that's something we came up with. There's no community standard on how to do that. And honestly, people, including researchers who are like going to use these data sets in publications, spend variable amounts of time on that document, and some people do an amazing job, and we get like a 4-page thing that's very rigorous, and other people write the bare minimum in each field, and so enforcing that is challenging and frankly time consuming because like one of our staff you basically have to go then have a conversation with that PI or grad student about like, oh, we feel like this is not quite adequate. Can you spend more time here? And that's labor intensive. So that's another piece of the sustainability kind of issue is how you handle that. So if you poke around at Open Topography, you'll find some very, very thinly documented data sets and some really richly documented data sets. Absolutely. Yeah, great.
That's true.
Great point.
Yeah. All right, Dawn, are you able to share your screen or did you want me to share your slides? Dawn Sullivan. Hello, Dawn, are you with us?
Yeah, okay. I've got to mute in 2 places. Can you hear me?
Can hear you okay. Like
all right.
Medium well.
Medium well. Okay, I'll speak up. Okay.
And if you'd like, I can share your slides from here, I believe, if that's easier.
Okay, my browser is fighting me. Bear with me just a moment here.
Yeah, no worries. Actually, while you're doing that, Dawn, feel free to jump in any time as soon as you're ready, but I'll direct another question Jane had to Chris. Do you think there are other domains that would and or should most easily replicate your tool stack for their data? So maybe thinking beyond topography.
That's a great question. Like, I mean, some of the things we've done for topographic data are also essentially also applies to like imagery data sets, and those kinds of things, or maybe like vertical outcrops, like that kind of structural geology type of applications. I know less about like some of the other environmental environmental sensors that are flying. Since you worry about it, texture, air quality, or something like that. So I have to think about that question.
Okay. All right, circling back to you, Don. Any luck?
I'm still working on it.
Well, how about this? Do we want, maybe we can just
Okay.
flip to Chuck. No worries. Well, maybe we'll
Why
have
don't you,
Chuck present
have a
and
Chuck.
then we can come back to you right after. How
That'd be
about
great.
that? Okay, great.
That'd be
Chuck, are
great.
you okay to go?
Sure.
Wonderful, thank you.
Okay, and start slideshow. Can everyone see my slides and hear me?
Yeah, everybody, it looks real good. Thanks, Chuck.
Excellent. Okay, so this is a long presentation, but I'm going to go very quickly through it to make it through the time. So this will be in the ESA Figshare after. So I put a lot of references and links and stuff like that, so you can go and look at the information. The project is called Linked Data API for Network Drones, Landers. And this is a Sloan Foundation funded project between myself and Jane Weiger, who will be who's part of this group and we'll be talking at the discussion section. Okay, so first of all, our approach, we use a sort of modular extreme design methodology for ontologies, which provides a foundation for fair data, particularly the interoperable part of fair data. And if you're interested in how to use modular design to do this, there's a great paper which I linked to here. Okay. As part of that, we have a workflow where we essentially from the ontology generate the ontologies themselves are fair data objects. We develop human readable documentation straight from the ontology, the linked data that's inside of it. And so you can dereference the documentation, you can see exactly what we're doing and understand what's going on. It's all versioned, and so you know which version it is there. There's links through provenance to previous versions, so you know if something's changed. We use GitHub for doing this development. And so it lets us version the actual ontologies inside as data objects themselves, and it lets us do automated testing, build scripts, all those sorts of things. And it's also fair in and of itself that it's dereferenceable through essentially GitHub pages and W3 IDs. And so if you don't know about W3 IDs, they're persistent identifiers. And so the ontology place can change, but it will always be dereferenceable. Okay. We use standards, right? And so one of the things that we're doing is we're linking to either OGC or W3C standards. So we link to Geospatial to provide the standards for all the spatial information that's part of the ontology. In particular, we are now linking to the development version of the new 1.1 version of Geospatial, which gives us this idea of spatial object collections and feature collections, these better ways of sort of describing collections of spatial objects, say like a trajectory. We use the semantic sensor network ontology, which is a W3C standard, just like HTML is a W3C standard. The time ontology, once again, and also something that we helped develop along with Simon Cox and Adam Shepard in ESA, the temporal extensions to all time ontology for temporal aggregates. And those are, once again, collections of temporal information. Because of the modular design approach, we can also link to other modular ontology efforts. And so OGC testbed 16 had an aviation testbed. They used modular ontology design. It was sponsored by the FAA. And so because they were using this modular design of an equipment module and an aircraft module, which used PROV as sort of this top-level ontology, once again, a W3C standard, we could very easily incorporate that and link to that, just very, very straightforward. And so I should mention, we've extended their ontology to a general concept of a vehicle. So even though our ontology, takes into account UAS, it can be used for any type of drone. So watercraft, surface, all of these sort of autonomous vehicles are also encompassed by the ontology. And so this idea of a flight ontology in terms of a mission is also incorporated. Okay, so that's part one, is creating sort of lightweight ontologies linked to standardized vocabularies that allow for standardized structure data. The second part is, okay, how do we then, create instances of that information that are sustainable? And so one of the first sort of experiments we did as part of this project was developing our own sort of vocabulary service and server. And the problem with that approach is that it's not very sustainable, right? As soon as this project is over, the money runs out, then you tend to no longer be able to maintain those things. And so we started exploring using Wikidata. And if you're interested in what Wikidata is, or how to leverage that, there was at the ESIP winter session a plug in the ESIP YouTube channel. There was a session called Wikidata, a knowledge graph for the earth sciences, where we basically have an entire session that talks about Wikidata. Had folks from Wikidata come in and sort of talk about it. It's run by the Wikimedia Foundation. It's a sustainable place, right? And so, for instance, you can create within Wikidata. It's editable by anyone that uses a wiki interface. You can create, pages and persistent identifiers for your project that then uses the Wikidata ontology to describe what this thing is, and it becomes searchable and findable. So, for instance, there's a linked data API for network drones, which is a research grant, a research project that's now part of it, which then links to our sort of landers.org page, right? We created as part of this project, and Jane's going to sort of talk about that a little bit, hopefully if there's time after this, a science data drone that is a sort of reference design. And so we can create an identifier for a science drone that if somebody is using that design, they can include it in their metadata, and we can discover more information. All of the 3D, sort of designs and all the information in order to produce this thing are also sort of linked to by Wikidata. The design set, so the actual thing itself, there were a couple different designs. One's a multi-rotor hexacopter. We'll show, hopefully have time to show a video, but it gives us the ability to say what it uses, right? And so it has part of this orange, cube orange standard set, which is a set of autopilots, right? We can then link to a design set, which is the actual set of designs that talk about it. Wikidata has a nice sort of thing is that they use machine learning to tell you relevant sort of properties, things that you can do to annotate your data to make it better. And so this is a pretty nice way of saying how complete is my coverage in a knowledge graph. You can link to sensors that are already there, right? And so, for instance, the 6-axis motion tracking device was already there. You can basically link to it as an identifier. It has links to the documentation. It has properties that it's a gyroscope and accelerometer. You can tell what kind of protocols it uses, all kinds of information. The orange cube standard set, right, for example, which is the autopilot that we're using, it basically tells you which software it uses, has part of those two sensors, right? And so you can basically extend these out into larger knowledge graphs. It has an API, and that API is a linked data API. I can query things as a graph, but I can return things as JSON objects. And so that means I can build software fairly easily based on that. Just like GraphQL, it has a similar sort of interfaces, right? Okay, so then the other part that we did was a little bit of direct prototyping. So this is sort of from the other presentations that we've heard, this is at the other end. Can we create data collection companion computers and sets of software that open science projects can reuse that then help to annotate and create better data, right? And better data reuse. And so we created a few prototype linked data platforms based off of some Python software. We use something called Shackle. And so Shackle is a W3C standard for constraining a graph. It's sort of like JSON schema. And so you can basically check to see that the data shapes match what they should match, and can flag issues with the API. And so this is an example of the API using those sort of standardized vocabularies along with linking to those Wikidata objects, which you can see sort of in the response from the API prototypes, right? And so, for example, a sensor shape can map directly to the sensor that is in Wikidata that gives you more information. you can generate web interfaces straight from a shackle shape. And so we have a little tool that basically, based off the shape, will generate the user interface that will let you put more information in. We can then data mine as other sorts of sensors and things come available in Wikidata that can automatically get pulled in and added to your options. You'll also create ones that are not there, and that can also be shared back to Wikidata potentially, right? And so you have this sort of interactive distributed knowledge graph. Okay, so the last sort of thing that we're working with now, and this is just sort of the last parts of the project, is can we, take this little prototype that was sort of one-off and start to generalize that on more better sort of software, so to speak. And so there was a project and a company that's formed called Inrupt, which Tim Berners-Lee, father of the World Wide Web, has founded in the last 2 years. And the idea behind this is essentially decentralizing human, sort of social network data and other sorts of data that belong to people. But it can also be leveraged for scientists, individual scientists, to distribute their data, right? And so there's both a corporate sort of a model, and there's also then a community model. It's all open source software. They are trying to build community behind it. So there's an open source community solid server. It's all based on linked data principles also. And so can we create individual data pods, right? This is the Inrupt. I should mention that they've gotten quite a bit of sort of buzz in Europe. And so Flanders is basically building a digital economy based on data pods for all of its citizens. So that provides a lot of sort of sustainability and community to build products on top of that, right? And so the idea here is that these things are just decentralized, right? And so instead of a sort of centralized Facebook sort of set of applications, these are decentralized sorts of web applications that different applications can talk to different data pods for different reasons, but the metadata is there in order to connect everything together in these decentralized application environment. And so all this is done through this RDF, which is this linked data, and gives us the ability to then create fair data pods that scientists can use and control. The nice thing is that because it's privacy oriented, it automatically implements web controls and all these sort of access shares. And so, scientists, as they're collecting data, when they want to share data, they can, but if they don't want to share data immediately, they don't have to. And so it gives the control to the scientists as to when and where and how they want to share and analyze data. And so the sort of general design of this is using essentially Balena as a distribution platform. And so we want to create containerized, essentially pods that then can be pushed to a companion computer, can connect to either existing pods, or in the case of our drone reference design, are integrated as science payloads directly on the pod, or excuse me, on the drone platform, and talk directly to Mavlink to pull in information, but can pull in information from other sensors that are part of it. And so it's a development environment that is sort of based off of the Internet of Things and these sort of platforms which are also sustainable and have a lot of uptake. In that, I will give a set of acknowledgements. I apologize for sort of going quickly, but I'm hopefully have kept this on time here.
Yeah, thank you, Chuck. I really appreciate that. That was, yeah, awesome. That was quite a whirlwind, but a great picture of all the work that you all have been doing with Landers. So that's awesome. So Dawn, we are going to flip to you. So if you want to try to start to share your screen, maybe while we can take one question for Chuck, if there is one.
Sure. Let me give it a try.
And Chuck, I guess I have one that I hope makes sense. But when you were talking about the sort of companion sort of
Computer.
data management piece that goes
Yep.
with like a drone collection, I was wondering, like, as I was thinking about Chris, your work with open topography, I was like, oh, is that like the kind of thing where you're like, oh, we know what like a place like open topography might need to be collected, so like you could like have a template and be like, oh, if somebody's collecting this kind of thing, we could like implement, is that the kind of
So
like relationship?
so that's exactly it, is that the idea is to push things, like I said, to a decentralized set of environments where then if you want to share data with open topography, or you want to share data with the Australian, data service, or you want to share data with your publisher, or whatever those cases are, you can essentially transfer or share those parts of the data. There's provenance graphs that are part of this, right? And so you have all of the sort of collection information that's part of there. There's also just base information about what equipment, which drone, who is the operator, who's the owner.
Yeah.
Those are exposed to through sort of the same sort of ideas and standards that the FAA is kicking around for the next generation of air traffic system in terms of what the structure of those data messages should be. And so it's all in that same environment. And then the idea is that we should have connectors, right? So these applications that are agents that then can connect to different sets of software. So if you have a camera and some sort of data acquisition system, you can connect to that that system by writing an adapter that then organizes the data. I mean, the command you appeared. I mean, these are just essentially Raspberry Pis. I mean, it's the quick hack that most of most of the drone operators are doing. That you have a Raspberry Pi that collects the data that's coming off of a camera or coming off of a system, and then that goes to some solid state drive somewhere. And the idea is that we provide some structure at that end when you're doing a mission planning, even. And so the route and all those sorts of things can be entered information as part of what that data collection actually is, that activity.
Oh, wonderful. Don, I'm curious, are you able to share your screen?
Okay, can you hear me okay, first off?
We can, yeah, can hear you.
Excellent. Okay, now when I go to share, it says that the, okay, wait a second, now it's different. Our screen.
It looks like it's working.
Alrighty, so you see my screen, or do you see? Okay.
Yeah, we see your screen, but right now it's the Zoom, so you need
okay. Alrighty.
You're close. That's a really beautiful volcano.
Yeah, that is from a conference I attended. That's from the IIVCI website, the International Association that deals with volcanology, and I was there coordinating a agreement between them and the Open Geospatial Consortium to start standardizing volcanology data. So it was pretty cool.
Great.
All right.
Yeah, we can see it if you want to go into full present mode.
Okay, let me. Why can I do this when I'm not on the spot?
No worries. Yeah, maybe presenter view.
All righty. Is it in presenter mode, or do you see my screen?
Yeah, it's a little laggy. We can see your notes, I think, or like the next slide. So I don't know if anybody has a quick, maybe at the very bottom there's an icon. I don't actually know PowerPoint well enough.
Yeah, I'm just going to go to a regular here. How's this?
Yeah, that looks great. Thank you, Don.
Okay, yeah. Yeah.
And we are running a little tight on time, so if you could try to keep it to 10 minutes, that would be amazing. Thank you.
I thought we had another hour and a half almost.
Oh, no, I think we're done at 5:30, I believe. Is that right? People? Yeah. So just, yeah.
Oh, boy.
But excited to hear what you have to say. So.
Okay, I'll make this really fast.
No worries. Okay, thank you.
I'm going to give an overview of NASA's involvement in open data, open standards, and UASs, and it goes back to the mid 90s. In 1994, NASA was instrumental in the formation of the Open Geospatial Consortium, and in 1997 we started flying drones and delivering data remotely. One of our emphasis has been consistently on open standards, open data, and network communication. So we flew some solar-powered drones back in the 90s, and I'll go through this pretty quickly. We moved to a series of internal combustion engine, in this case Rotax drones, primarily looking at fires. This was the first time that we used Open Geospatial Web Map Service standards to actually display the data. We are very heavily involved in using OGC standards, and I'll talk a little bit more about that later. The next generation of that was we were going from this vehicle right here is a modified Predator A. We worked with General Atomics to make a vehicle that would fly longer and higher. This is what they came up with. It was called an Altair. General Atomics liked it, NASA liked it, but there were some modifications made to make it more producible and more effective. We've been involved in, I got a slide out of place here. Okay, yeah. This was the Predator B. This is the one that came out of the modifications to the Altair. In the interim, we were also working with small UASs. This is an APV3. We put a telemetry package on here and a radio transmitter package on here, and worked with the Forest Service in 2006 in a communications relay experiment. It turns out that when you have a fire in the mountainous areas, it's not a problem. They put a repeater on top of the tallest mountain. But when you have a fire in areas that are relatively flat, in plateaus that have canyons, you have real problems because the fires burn in the canyons and there's no high spot to put a radio. And we used one of these to transmute Forest Service radios. It worked really well. It gave us an idea that we moved on further on. We operate a fleet of Global Hawks, high altitude, long endurance platforms, fly at 65,000 feet for 30 hours, 32 hours, and we've used them in all kinds of science operations. This slide deck is downloaded, so you can read this yourself. I'm not going to read it to you, but we've flown a bunch of different things with it. We're operating now a series of smaller drones. We realized that sometimes you're going to lose a drone, and so they should be relatively inexpensive. So we worked with a drone that was developed in the military called the Dragon Eye. We've modified it a bunch of times. We've flown volcanoes in Costa Rica. We've flown volcanoes in Hawaii, flying through the plumes, collecting data, and again, getting it back down to the ground in real time and using open standards to display them. Currently, we're operating a vehicle called Sierra B. It's a vehicle, a moderately sized UAS that will carry about 50 kilograms of payload, can operate autonomously, can operate over line of sight, beyond line of sight. We've flown this over the Arctic. We've flown it in a lot of really, really cool places. This is something that's not in the slide deck that I uploaded because it's still preliminary, but it looks like it's going to be a go. We're now going to use a balloon UAS. It's going to be carrying both radio telemetry relay equipment in LTE bands and LoRaWAN, and also collecting infrared data over fires. We're working with the U.S. Forest Service on this. It's pretty exciting, and it's gonna work really, really well. NASA has participated and still participates in a lot of data standards organizations. I'm going to go through a couple of them here briefly, but the ISO TC211 Geographic Information Standards. We participate in the Open Standards, Open Geospatial Consortium, uninhabited, uncrewed systems right now, domain working group, and the moving features domain working group. I'll bet everybody on the phone and in the meeting here is familiar with the Open Geospatial Consortium, but I found that a lot of people are not really tracking moving features, and I think that's a real lack. They're doing some really amazing things in defining where something is in forespace, which is something we all need, of course, but then where it becomes particularly applicable to the drone community is they're defining where things are in forespace with vehicle orientation, which is really amazing, and it's something you really need for doing anything, geolocating, georectifying, drone data, or even data from a non-satellite platform where you've got some roll, yaw, and pitch. In any case, we're also working with the Geo Data Working Group, UNGGIM. We're liaison to them, and we're working with the Motion Imagery Standards Board, which also is a data standards organization through NGA for drone data. Now, that is the end of my official presentation, but I'd like to bring your attention to a couple of other things. There is now, inside the Open Geospatial Consortium, a unstaffed system command and control interoperability experiment. We're in the midst of writing the white paper on it right now, but it's got international coordination. Kongsberg, I'm not going to read it to you, but there's a bunch of people on here. I can put a link to this in the chat, but this is the first cut to a standard, a interoperability standard for command and control of UASs that is going to work for underwater, surface, or air vehicles. it is really exciting. We've gotten so far as to do some real things with it. Let me see if I can call this up next. Yeah, okay. We're actually defining, data models and making sure that we can interoperate transnationally. We've got servers and operations in the UK, Germany, France, and the United States, and again, really exciting. See now, there was. Oh yes. Well, no, that was I wanted to. Yeah, that's pretty much what I wanted to cover. I'll leave it at that, and I'll open to questions and open to questions, and I'll try to give you back a couple of minutes.
Wow, thank you, Don. That was so fast. So you were just showing us the that was an OGC working group. Is that the one you were?
Yes, it's actually a interoperability experiment which grew out of the uncrewed systems domain working group. Working groups in OGC can spin off either a standards working group, an interoperability experiment. They get involved in test beds. There are a number of rapid software deployment efforts. So there are a number of things that come out of the domain working groups. This particular one, this interoperability command and control experiment.
Great.
Okay. Has been going now for a while. We're about to publish the engineering report and go into phase 2. It will probably be part of the test bed. I guess it's going to be 19 also, and we expect to have significantly more funding for this one too. NASA being one of the big funders.
Yeah, that's wonderful. If you would maybe stop sharing your screen, and then I'll put everybody on the screen so we can all see each other. And in the meantime, does anybody have any questions for Dawn specifically? Oh yeah, Jane did. Jane's asking you, Dawn, how should we follow or engage with UAS CCIE specifically?
Let's see now. I'll put the link to the interoperability experiment page in the chat, and get in touch with me, and I will be glad to get you involved. Jane, I think you may already be registered. You're a member of the OGC, I believe, and you're already registered, so you have no problem at all. But yeah, and we encourage additional. We encourage additional following of it, contributing, commenting, looking at the data models, making sure it works for them too. It's an open program, an open standard, and we encourage collaboration to the greatest degree possible.
Great, thank you, Don. Okay, so with that, I mean, those were our 4 awesome presenters. Thank you all so much. Such a good, I think, breadth of just sort of experience here. I want to open up to maybe general discussion or questions for anybody in particular, and maybe keeping in mind, so we have, I want to end on time. There's funding Friday and fun things after, so we have about 10 more minutes. So general conversation, but maybe also in mind with questions like, this has been such a wonderful group and space to like come together and talk and share across different different groups and different experiences and different ways that people are using drone data. So like also maybe adding some feelings around like how you might want to see this shape and go forward too. But just a suggestion. Yeah, thanks.
So you have a question for Chuck?
Yeah,
if he
Chuck.
doesn't mind. 2 questions. The first one is, do you have an ontology?
Well, you just broke up.
I just
that's my turn. My fault. We can't unmute. Repeat, please.
Yeah, okay. Are you ready? Okay, good. This is a question for Jack. Jack, do you have ontological mapping tools of your system? That's the first question. The second question is, have you tried to use a COR or PCFed for your ontology work?
So the ontology work that we do, like I said, we're not using any test bed or other tools other than the design patterns themselves. There's something called a model design pattern library, and also the design patterns that OGC came up with in their test bed, which are essentially event, activity, sort of basic sorts of things. And the data models were published as part of their engineering report, so it was pretty easy to reuse. The first part of your question, I'm not sure I understood.
Just for me to quickly explain it, is that there are some of these vocabularies that exist out there that are very similar to the vocabularies that you're probably working on. And I was wondering if there are any mapping tools that you have in your system that will allow you to traverse these ontologies.
Yeah, so the pattern-based approaches are pretty good for doing alignment and merging. We don't connect necessarily to domain vocabularies other than concepts that are already available in Wikidata. And so we sort of use Wikidata as our universal translation layer to some extent. There's crosswalks that are being built in terms of suite and other sort of earth science ontologies to Wikidata. And Wikidata actually has this ability to connect to external identifiers. And so if there's a term in Wikidata that then matches some other vocabulary or ontology, you can create external identifiers for that ontology, then link to those terms, which is pretty useful. Most of what we've done is at a higher level than, say, a domain feature vocabulary, which would be, you're doing data collection for some geologic feature or something like that. You want to describe that in more detail. Then you would need to use the linked data principles plus maybe a little design pattern to get you to that connection to that thing that you want to talk about, but leaving those at sort of the domain level, if that makes sense. Hopefully that answered your question.
Yeah, he says yes.
Okay.
Yeah, thank you, Chuck. Matthew, I don't know if you saw in the chat, there was a question for you from Jane, if there are any plans for an ML pipeline in ASDC.
Yes, but it'll be further down the track then. I'd love to see it happening right now, but yeah. So the short answer is yes, but let's get the important stuff, the real core functionality completed first, and then we'll triage all the fun features after that.
Thanks. It was good that it's in the pipeline or in the vision though, because
certainly
architecture has to support that. That's great. Thanks.
Any other questions in the room or online, or just sort of discussion points? Yeah, go ahead, Jen.
Maybe I'll ask a slightly lower level question. So I use X4D, Agisoft, and WebODM, and I've seen a few semi-structured comparisons of structure for motion outputs from those, but I'm wondering if this group might be an appropriate forum to try and do like a white paper of, I hate model bake-offs, but for lack of a better term, a model bake-off and sort of robust assessment of these outputs based on a common set of data.
That's a good question. I'm actually wondering if anybody's already done such a thing or knows of. I feel like if Joe Adams were here, I feel like he was doing a lot of this. But Matthew, maybe first, and then maybe Chris.
Yeah, sorry, nothing formal. I've used every photogrammetry or structure from motion engine under the sun for a whole raft of different applications. I come from a commercial drone services space, but now in the research area. But look, yeah, nothing formal. But if there's one learning I've taken away from using all the software available, is that each piece of software has its strengths and weaknesses for different applications. So as you said, trying to define an objective measure of accuracy, precision, reliability, or to be able to define what software is best or what model is best used when would be extraordinarily helpful, but a difficult task. So if there's anyone here who's up for that challenge, I certainly yeah, encourage it.
Yeah, Jane.
Yeah, it's been a year or two since I've looked, but I agree it's difficult to quantify, and the approaches are quite difficult. I have seen some papers, like more than 5 years ago, there were a couple of papers. This might be a good idea if we could focus on something that the ESIP community particularly cared about, a particular application, for instance. I feel like this cluster could support enabling that kind of review.
Yeah, no, I think
yeah,
go ahead.
Sorry, it's a common question. It's one of the first things that a lot of scientists who start trying to use structural motion from drones ask, like, which model do I use, which tool? And so maybe if there was a community, I feel like Chris must have expertise in this, within ESIP that particularly wanted to answer that, we could work with them to answer it for that application.
And I don't know, Chris, if you have anything to add. No, okay. Yeah, I believe, yeah, it would be interesting. I know at the USGS, with the UAS group there with Joe Adams, I'm pretty sure they were doing some comparisons, sort of trying to be a little bit more robust, but it'd be interesting to see where they are now, and they've interacted and sort of been a part of the ESIP drone cluster for a while. So it'd be cool to like think through that. But yeah.
Yeah, I was gonna say one of the things we talked about but never done is like creating a suite of benchmark data sets inside of topography and different landscapes, collecting different technologies that can be used as like an input to that type of exercise.
Yeah, interesting.
Like just as like people are developing new processes and workflows, they can go grab a set of data that's to use it as a test case. So it's not directly related to something.
Yeah. I like that potential direction. Yeah, we'll think about this more. So I do want to we have 2 minutes till 5:30. So if there's any other quick burning questions, we can maybe address them. So I'll give a space for any quick burning questions online in the room. And if not, which is totally fine, I'll just say that I think, we had, Jane and I were talking about like, okay, drone cluster going forward, like where's, the best places for us to collaborate? How do we continue to like talk? And I think that, it sounds to me like there might be some energy in maybe thinking through actually like this last topic that we just discussed a little bit, or like, coming together and thinking a little bit more about that, and maybe having a couple more drone cluster calls before the next ESIP meeting. Sounds like it might be in the cards to kind of talk through and get people together if there's interest. So I guess I'll just open it up to anybody online in the room that was here, and also we'll send it out to the listserv, but maybe we'll choose a time going forward. I actually don't even remember when our official times are, but if you're interested in joining a drone cluster call to kind of talk through a little bit more about like directions, collaboration points, like maybe some projects that we could kind of like start to envision for the coming winter session, or January session, sorry. That'd be great. And if you are interested, please drop me like a little message in the chat if you're online, or if you're in the room, maybe come up after and I can take down your information and we can make sure you're on the list serves. And yeah, and then we'll look forward to having another session, of course, next ESIP meeting, but also a couple cluster calls before then to help bring more ideas together. So yeah, happy to talk afterward, and please, talk to each other as well. And Jane still has questions, so great. You guys can keep chatting online, of course. But we'll officially end this session. I hope to see you all at Funding Friday. And yeah, feel free to chat after. So thank you.